Number 1, w squared minus 3w minus 40 over w squared minus 14w plus 48 plus w squared minus w minus 30 all divided by w squared minus 3w minus 40. So what I'm going to do is I am going to look at this and realize that this is not an equation, which means that I have certain rules that I can and can't do. One, I cannot multiply everything by the same number because it is not an equation. So the only thing I can possibly do is make these guys have the same denominator. So the first thing I'm going to do is factor, and I'm going to factor everything, and then we're going to talk about something that's kind of happens that is a little weird in this question. So we're going to factor everything. The only reason I'm really factoring the top is maybe it cancels out and makes my least common denominator a little easier to deal with. I'm not going to talk too much about factoring. I'm going to kind of go through it quickly. We should know how to factor now. So this should be w minus 8, w plus 5. This one should be w minus 8, w plus 6. And this one should be w minus 6, w plus 5. This one is w minus 8, w plus 5. Now, what we're going to look at is we're actually going to think about canceling out and the least common denominator together to see if it would help us out. So one of the things is right here, I could cancel out this w minus 8. However, if I look, this denominator has a w minus 8. So if I cancel this w minus 8 out and I cancel this w minus 5, I'm going to realize that the least common denominator is going to be w plus 6, w minus 8. So my question to you is, why would you cancel this out when you're just going to have to bring it back anyways? Meaning you would have this down here, and what would you have to multiply this by? You would have to multiply it by w minus 8 and w minus 8. Why would you cancel it out just to bring it back so that they have the same denominator? So that's what I was meaning by this is a weird case. So instead of canceling it out, I'm actually going to leave this w minus 8 alone, and I am going to cancel out this w plus 5. The reason I didn't cancel this w minus 8 is this one had it, so later on I'm going to need it anyways. So I'm going to realize that the least common denominator is going to still be w minus 8, w plus 6. And then I'm actually going to put this back into standard form because when we go to add the tops, we're going to want it in standard form. So I'm going to go ahead and kick it back to its original state. I realized that when I factored it, it really didn't help me to try to cancel anything out. In the first one, and the second one, it did help me out because I want to get rid of that w minus 5 because that makes my least common denominator easier to deal with. So hopefully what you can see right here is this is just w minus 8. That means it's missing a w. Is this plus 6 or minus 6? Oops, that's a problem. My bad. That's supposed to be a minus 6. So that means my least common denominator is w minus 6. So then I come here and I go times this equation by w minus 6 times this by w minus 6. Doesn't matter if you put it in the front or behind it. And then I'm going to have my denominator as w minus 8, w minus 6. And then I'm going to distribute this, and that is a perfect square, so you should be able to do that quickly. It's w squared minus 12w plus 36. Now, since I made my denominators common, which was the goal, w minus 8, w minus 6. Now I can combine things. W squared and another w squared is 2w squared. Negative 3w minus 12w is a negative 15w. And a negative 40 plus 30 is a -4. I would try to technically factor this top. However, when I do, it's not factorable. So this would be my final answer. This could be the final answer, or they might distribute this out. So if you don't see this answer there, you might have to distribute this bottom, combine it, and then get the standard form, both top and bottom, and that might be your answer. However, this is the answer choice that is there. Any questions on 1?
I have a question.
Yes.
Why didn't you cross out the W minus 6?
Oh, very good question. What is this, Nina?
A plus sign?
That's totally different than multiplication, isn't it?
Oh, okay.
Multiplication, we can cross cancel. In addition, we cannot. In addition or subtraction, you can cross things out that are over the top of each other. In multiplication, you can do them over the top of each other and across. But since this is addition, we cannot use that rule. That's what I've been trying to get you guys to focus on this entire chapter, is knowing the rules and when you can apply them and when you can't. Does that make sense? So it's a good question, Nina. Did that help?
Yeah.
2. Again, I do not have an equation. So what I do to one side, I cannot do to the other. So that whole idea is out. So the idea here is I need to make them have common denominators. Before I can do that, I need to factor this. I should realize that that is a difference of squares very quickly, which means m minus 9, m plus 9. I should realize that my least common denominator, what can I make them both become? I can make them both become m minus 9, m plus 9. So this guy needs an m plus 9, so I have to do it to the bottom and to the top. And when I do that, both denominators become m plus 9, m minus 9. So now I have common denominators. Distribute this out, 8m plus 72 plus, there was nothing that was here, so that stays the same. Now the whole purpose of this is combine the tops, keep the bottom, so m plus 9, m minus 9, and then 8m doesn't have anything combined with, so it's just 8m, and then 72 plus another one is 73, and there's my final answer. Questions on number 2? Number 3. A squared minus 11a plus 24 over a squared minus 5a plus 6 minus 5 over a minus 2. So here we're going to factor both the top and the bottom just in case something cancels out. It might help us. If you want to do this on the side, that would be good. But really, all we need is the bottom factors, because then we can make common. But sometimes, like I said, we can factor the both top and bottom because maybe something will cancel. This will not always happen. So I take this is like my side work. Come over here, factor the top. This should turn into x plus 8, x plus 3. This bottom should turn into a x. Oh, I lied to you guys. You guys should. I'm sucking right now. This says same signs, Mr. Martin. This says both negative. So this is minus 8, minus 3. This says same signs. This says both negative, and this is a negative 3 and a negative 2. Since these guys are on top of each other, I am going to cancel these out. And so I'm going to change this to x minus 8 over x minus 2 minus 5 over a minus 2. Now, I am going to be careful with this subtraction sign. I do get a little lucky on this one because I don't have anything. There's nothing that this 5 is multiplying by, like there's no x minus 2 here, which makes this a little simpler. If there was, you'd have to distribute the negative. Don't forget that. But since there isn't anything, And now, oops, this is an A. Since the denominators are the same, I can just combine the tops. A minus 2. X has nothing to come. I can combine the tops. X has nothing, so it's just X. I have a negative 8. I have a negative 5. That makes negative 13. That should be an A. And there's my final answer. Questions on number 3? All right, moving right along. Number 4. Since I do have an equation, this is different than any other problem that we've had before. This equation, there's a couple ways I can do this. I can multiply both these things by the least common denominator, or what you can realize is you can just cross multiply. Now, when we cross multiply, we multiply this top times this bottom, and that goes on one side of the equation. We cross multiply this times this, and that goes on the other side. So 5 times x is 5x. 5 times 4 is 20. Negative 3 times x is negative 3x. A negative 3 times a negative 1 is a positive 3. I am then going to combine like terms. I can isolate this one fairly easily. So I'm going to get the x by itself, meaning move the x over to this side. Then I'm going to move the 20 to the other side. Can do that all together. Cancels, cancels. That becomes 8x over here equals negative 17. Divide by 8, divide by 8, x equals negative 17 eighths. That could be your answer. Technically, you have negative 2 and 1/8 as an answer as well if they took this and turn this from an improper to a mixed number. Questions on number 4? All right, number 5, we are back to not an equation. Let's see if we can do some side work, see if this right here, see if this fraction has anything that cancels out. Maybe it makes my problem a little easier to deal with. So we go take this to the side, b, and this would be minus 7, b plus 5. Down the bottom, I would have b plus 6 and b plus 5. And when I do that, cha-ching, these guys cancel out, which is nice because then I look and I realize that these guys, when I cancel out that other part of the denominator, now have like denominators, which is important for me when I'm adding them. So since I already have common denominators, I just add the tops. B, a negative 7 plus 5 is a negative 2 over b plus 6. Please do not try to cancel out these b's. Do not do that. They cannot cancel out. B minus 2 over b plus 6 is my final answer. All right, so it looks like we are halfway through. Any questions on that number 5? Number 6. When I see fraction over fraction, I'm thinking I like this one. Why? Because I have one fraction divided by a second fraction. So right away, I can just change the way this looks. I'm going to go y minus 2 over, I'm going to factor this while I do this. This is going to turn into y plus 7, y minus 6, and then I'm going to write divide instead of this bar. That's the divide right here. And then I'm going to write the second equation, or fraction, y minus 3, y minus 6. Technically, I should be thinking about the exclusions, so y can't equal -7 or 6. The book doesn't seem like it's caring about the exclusions as much in this section. It really should. Then y minus 2, I keep the front one. We do not divide fractions, so I keep my front one. Whoops. Keep, I change, and I flip. So this becomes multiplication, and we have y minus 6, and we have y minus 3. And technically, y can now not be 3 either. And I say, okay, now, Nina, the y minus 6 can cancel out with a y minus 6. They can cross simplify. Why? Because that's a multiplication table different than the other one. And nothing else simplifies, so top times top. Since this turns into a 1, this is just y minus 2 over y plus 7 times y minus 3. Again, that should be one of my final answer choices. And if it's not, remember the order of these bubbles doesn't really matter, so they could be y minus 3, y minus plus 7 on the bottom. That really doesn't matter. Maybe they distribute it out, maybe they put it in standard form, so you might have to look for those different answers. But that's the process. Questions on number 6. Number 7. I do not like the way number 7 is set up. The reason I do not like it is I don't have one fraction in the top and one fraction in the bottom. I have two fractions here and I have two fractions here. So the first thing I need to do is make these two become 1, and then I need to make these two become 1, and then I'll make my life much easier for dealing with this. So, this is a 4K. So let's deal with the top first. So we're dealing with that. How in the world do I make these guys become the same denominator? Well, they both have a k, which is cool, so I don't need any k's. If this was like k squared, then and this is only k, then you would need an extra k, but it's not. It's just k and k. So then I go, okay, how do I make 5 and 4? What number can I make them both become? And the answer is 20. So I have to times this bottom by 4, but that means I have to times this top by 4. That means over here I have times this bottom by 5, and so I have to times the top by 5. And what I end up with is 4 over 20k. It's like I'm unsimplifying the fraction, minus 20 over 20k. If you notice, 4k over, or 4 over 4k is really 1 over k. Well, same thing with 20 over 20k. It's really just 1 over k. Why? These two numbers are the same exact number. Just change the way they looked for just a second. I'm going to continue on with my top. My top is going to turn into a -16 because I can combine tops. 4 minus 20 is -16 over 20k divided by, and hopefully you can see these guys already have common denominators, which is at least nice. And 1 plus 2 is 3, so it'd be 3 over 5k. Now once I have it a fraction divided by another fraction, I can go ahead and keep, -16 over 20k. I'm going to keep this, I guess, like this for just a minute. So I rewrote this division problem like this. Why? So I can keep, change, flip. Technically, k is not allowed to equal 0. Like I said, they don't talk about that much on the test. -16 over 20k times, keep, change, 5k over 3. The 5k and the 20k, 5 goes into 20 4 times, k goes into k 1 time, so this turns into 1. And then a 4 can cancel out, and 4 goes into that 4 times, and that's a 1. So -4 times 1 on the top is -4 over 3 times 1 is 3. There's my final answer. Number 7 questions. Number 8, x plus 4x over y divided by 7 over 3x. All right, what I would do is, again, I don't like the way the top is written. It's got 2 fractions. I need it combined to 1, so this is over 1. So my least common denominator is going to be y. So I'm going to times this by y and this by y, which means my top is going to turn into xy over y plus 4x over y. And when I combine those, that's going to turn into xy plus 4x over y. Here is the tricky part. This is factorable. They both have an x in common. Remember, you pull out anything they have in common. So technically, the top should be x times y plus 4. That would be this factored. That's over y. That's that right there. Divided by, now I didn't have to do anything to my bottom because it was already 1 fraction. So now I have a fraction over a fraction, which means I'm going to break it apart and make it x, y plus 4 over y times, or divided by, sorry, 7 over 3x. You cannot cross cancel because this is not multiplication, so you can't cancel those x's out. Don't try to cancel those out yet. So then I get, keep a change, and I flip, and none of this stuff cancels out. So really you need to see this top as x times y plus 4 times 3 times x. And the reason I need you to see it like that is because then if it's all multiplication, I can do it in any order I want. So I'm going to write the 3 first, then the x times the x gets me to x squared, and then behind that is going to be y plus 4, and all of that is going to be over y. And that would be my final answer. Questions on number 8. Number 9. Now this one is different than every other one that we've done really so far, except for one, because this is now an equation. And when we have an equation, we're not going to make them have common denominators. Heck no, we're going to get rid of the denominators. And the way we get rid of that is by multiplying by the least common denominator. So I got to factor this guy, difference of squares, then I go, okay, the least common denominator, what can they all become? X plus 3, x minus 3. So I multiply this by x plus 3, this by x minus 3, this by x plus 3, and this by x plus 3, x minus 3. Now when I do that, goodbye, that's gone, leaves me with just a 6. Goodbye, that's gone. Now be careful because this is a -1, which means -1 times x is -x, and a -1 times a +3 is a -3 equals, this is just a 1, so all I have to do is multiply these guys together, which should be a difference of squares. You should be able to make that x squared minus 9 fairly quickly. Let's simplify this side real quick. -x, a +6, and a -3 make a +3 equals x squared plus or minus 9. Combine like terms, setting it equal to 0, so I'm going to add x minus 3, I'm going to add x, I'm going to minus 3. This all makes it equal 0. X squared plus x, combine like terms, -12. Solve by factoring. X plus 4, x minus 3. What makes this bubble 0? X equals -4. What makes this bubble 0? X equals positive 3, but then I look back at my restrictions, and I know up here, x can't be negative 3 here or here, because it would make the denominator 0. So then you are gone, and so x equals negative 4 is my only answer. Questions on number 9? Number 10. Now I am going to be careful of this one. Does anyone, while I'm writing this, does anyone know why I'm going to be careful with this one? I'm already starting to recognize, and you need to too. Why do I need to be careful with this one? Because it's subtraction. I'm going to distribute that subtraction sign probably, not now, but maybe later on, and make it addition. But I just have that in mind. So first thing I'm going to do is factor them all. Maybe some crap cancels out, makes my life a little easier. Same signs, both positive, x plus, z. Z plus 5, z plus 6. Different signs, bigger one's positive, z plus 5, z minus 4. This one factors into z plus 6, z minus 4. And this one factors into z plus 6, z plus 3. And when I do that, I realize that this is very nice because this cancels out and this cancels out. So that means what I'm really trying to do is take z plus 6 over z minus 4. Technically, I should be remembering my exclusions, which means z couldn't equal negative 5, 4, negative 6, or negative 3. But like I said, the book doesn't worry about it too much here. And then minus z minus 4 over z plus 3. Now I'm going to look for the least common denominator, which would be z minus 4, z plus 3. So I go, okay, since this is not an equation, I can't multiply everything by that. I've got to say, hey, what are you missing? Whatever you're missing, I got to multiply to the bottom and to the top because I'm really timesing by the number 1. That's the only trick I can use here. So this needs a z minus 4. And bottoms are both going to become the same. They're going to be z plus 3 and z minus 4. Both of them are going to be z plus 3, z minus 4. And then when I distribute, this is z squared, 6z, 3 more z, 9z, plus 18. And here, z squared, minus 8z, plus 16. Now this is what I was talking about. Right here, we do not subtract fractions. We're going to distribute it. That was going to make this a negative. That's going to make this a positive. It's going to make this a negative, and then I can add. So I'm going to keep my denominator, which was z plus 3, z minus 4, and then combine tops. A z squared and a negative z squared are going to cancel out. A positive 9 and a positive 8z is going to get me to 17z. And finally, a positive 18 and a negative 16 is going to get me to a positive 2. And boom, there's my final answer. That's a longer one. Any questions on 10? You can see, even with only 10 questions, you can't take your time. You've got to come in and book it out, and you should know the process of it. You got to know how to factor. Factoring is going to be a part of every one of these questions. And finally, a group of college students is volunteering for help for the homeless during spring break. They are putting finishing touches Working alone, Caitlin can paint in a certain room in 3 hours. So that turns into x over 3. And then plus plus x over 7. And together that will equal 1 room being completed. This one, your common denominator, because it's a fraction or it's an equal sign, so I can multiply everything by one number, is 21. That's the least common multiple between 3 and 7 and technically 1. This cancels out, turns to a 7. This cancels out, turns to a 3. And then you end up with 7x plus 3x equals 21. 10x equals 21 divided by 10 divided by 10. X equals 2.1 hours. And that would be the final question of the review.